In this video, I will show you how to use the calibration wizard in the SIMCA software. In another how-to video, I showed you how to import spectral data using the carrageenan tutorial example in order to set up a spectroscopy project inside SIMCA. We start the calibration wizard to create a new session. As you may recall from the data import video, the carrageenan dataset has three spectral datasets: NIR, IR, and Raman. We are using the Y block and the first Y variable, the lambda variable. We could choose any of the 5 Y variables inside this session. So I want to emphasize that the calibration wizard works with one Y variable at a time. If you want to make calibration models covering 2 or more Y variables at the same time, you have to operate outside the calibration wizard using the Home tab instead. We see down here that we have 128 observations, so we can click Next because there are no issues reported. Now we see the first page, or the second page actually, but the first page where it starts to happen things in the calibration wizard, which is the observations, meaning that we are now looking at the 128 NIR spectra. Here what we can do is to divide the data set into a calibration set used for model establishment and the prediction set used for model predictions, testing the model. We will here, just to show the principle, select the last 29 samples as a validation set, and we can then click here to assign them to the validation set. There are also other tools supported by the calibration wizard by which you can split the data. You can split by a secondary ID, or you can split randomly to get calibration and validation sets. We click Next to proceed in the wizard. That brings us to the variables page, where we see all the close to 700, all the 699 variables, spectral variables, wavelengths included in the dataset. In the default scenario, all spectral variables are included, but you can, if you want to, deselect certain wavelength regions where you think there is less information of relevance for the selected Y variable. I'm just going to show you one way to do that. You can, using the marker here, and highlight a certain section in the spectra, and then by clicking on the red cross button here, you can exclude the selected variables. Conversely, you can also include it. It works both ways. Now in this tutorial account of the capabilities of the calibration wizard, we will work with all variables being part of the training set. We are not going to deselect anything. Another little feature that can be nice to know about is that you can color the spectra by the Y variable that you have selected, in this case the proportion of the lambda carrageenan constituent, which is a nice little feature. We also have a screen reader by which you can read on the spectrum that you're highlighting and see what wavelength it is. And if you have highlights, this screen reader functionality can present results for multiple spectra at the same time. We click Next in order to proceed in the wizard, and now we come to the filter and compare page, which I think is the major feature bringing user friendliness for the spectroscopist. At this stage, in the left-hand part of the calibration wizard, you find 14 different filter entries. I will detail those filters in another how-to video. For now, I will only mention that these filters are grouped according to their objective. So in the top we have filters going for smoothing functions. The second segment are the baseline correction filters. The third group contains normalization filters, and the last group are other, which is containing MSC and derivatives. So what I recommend here is to start with a reference model. That is just to create the OPLS model on the unfiltered NIR spectra. So I click create model, and then that model is added to the model part of this filter and compare page. I can now start to select which filters I would like to try out. For instance, I can select multiplicative signal correction. Then upon choosing this spectral filter, a window opens up where we can see filter settings. We can see which spectrum is being plotted for the moment. We can see the original spectrum, and in the bottom we also see the filtered spectrum. By clicking OK, this filter is added down here, and if I now click Create OPLS Model, MSC is performed on the original spectra, and the OPLS model is fitted to the training set. I can now cross out, close or remove MSC and select another filter to add, for instance SNV, Standard Normal Variate. Again, we can see original and filtered spectra before and after filtering. I say OK, and now this filter is added. I can click Create OPLS Model, and then the third OPLS model is calculated. And just for the sake of demonstration, let's say we select to add a derivative filter. Regarding derivatives, we support 4 different derivative orders. I will, as I said, detail these filters in a separate how-to video. So now, for the sake of illustration, we take the first derivative and use default settings for the adjustable parameters. I click OK, and then this filter is added, and we can create an OPLS model also here. You can easily create 10 to 15 models in a session inside the calibration wizard. The intention with this video is to show how to operate the calibration wizard, not to exhaust all possibilities. So I will not add any more models. Now we turn our attention to the right-hand part of this calibration wizard, where we have the model performance part. And the objective here is to compare all the models that have been calculated in the current session of the calibration wizard. We can choose to view results based on the calibration set or the validation set. One plot that we plot inside this wizard when we look at the calibration set is a Q2 evolution plot. So we have 4 lines here, each one representing one of these 4 models. Another parameter that is essential when you develop calibration models is the root mean square error coming from the cross-validation routine. And here we want the parameter or the statistic to be as low as possible. Further down in the model performance part, we compare model statistics, and the green color is used to highlight the best statistic for a certain model. Inside the calibration wizard of SIMCA 17, we introduce a new statistic that we haven't used in earlier versions of SIMCA, the mean bias error based on the cross-validation routine. And this is a parameter that should be as close to 0 as possible, and the exact meaning of it you can read about in the help file in the SIMCA software. So I think you get the essence of this model performance part. We're comparing all the models that are calculated during the ongoing session. We will now turn our attention to the validation set, the spectra that we set aside in the first stage of using the calibration wizard. And in the model validation stage, we are using two tools. We have the RMSCP plot, root mean square error of predictions. It is analogous to the RMSECV plot, but based on the prediction set and not the cross-validation routine. The coloring scheme is the same as for the calibration set, and we would want this parameter to be as low as possible. In the statistics segment, we are, for the 4 OPLS models that we have calculated, reported the RMSCP and the MBEP, the mean bias error for the prediction set, using a table. We now click Next to proceed in the wizard. In the final summary page, we get an overview of the details behind each model, such as how many observations were included, how many variables were included, which signal preprocessing tool was used, and the setting of any adjustable parameter. When clicking Finish, we exit the calibration wizard, and we are now inside main SIMCA, where we can see that the Home tab partly has changed appearance in comparison with the shape or the appearance of the Home tab for a regular SIMCA project. Some of the tools that are now found here, such as the Q2, the RMSCV plot, and the compare model tables, they are summarized and reported inside the calibration wizard. In addition, we can see that the project window is now populated by the 4 models, and we can see that there is a title added automatically to each model that in a brief way indicates what each model represents, which pre-processing was done, and so on and so forth. This is all I wanted to show you in this little how-to video. Thank you for watching.